Welcome to the 8th class. With Dr. Sayed, we start the quest. Learn logical inference, my friends, the science on which the defense depends. From fragments, a hidden truth we find, using deduction, induction of the mind. Then abductive leaps connect it all, answering the cybersecurity call. Uncertainty fades as conclusions are made. A masterclass in the digital age. A masterclass in the digital age.
Welcome, everyone. Today we're diving into the exciting world of EInvestigations. Our main focus today will be on mastering logical inference. This is the core skill that turns raw digital data into concrete, actionable evidence. Let's get started. Analyzing digital evidence is not for the faint of heart. Look at the content here. EInvestigators need solid critical thinking skills. Why? Because you are often drowning in data. It's usually massive. You have to deal with gaps between known facts, assumptions, and potential conclusions. Remember this crucial point. Evidence isn't just on the computer. It also exists in the social context of the victim. To draw accurate and compelling claims about a security incident, you must correlate all that data carefully. Let's keep this chain reaction in mind. Every single investigation starts with collecting potential digital evidence. And here's a fundamental truth. Each relevant item of evidence leads to clues about what other items may be relevant. Think of it like a detective building a puzzle. Each piece of data is connected to another somehow, guiding you to the next piece you need. This slide is the core of our lesson today. To truly solve a case, an analyst must skillfully use the 3 logic models. Abduction. That's when you generate a hypothesis. Deduction, using facts to prove your conclusion. And induction, using experience to evaluate the evidence. Good tools are important, but it's the skillful application of logic models and critical thinking that solves the rest of the case. Don't just look at the data. Clues from behavior, skill set, relationship, location, and motive can significantly strengthen or weaken the case based on what's found on the computer. This is a quick summary slide, reminding us of those 3 key logic models. Abduction, where you form your initial guess or hypothesis. Deduction, where you test that guess with known facts to reach a conclusion. And induction, where you use your past experience to help evaluate the evidence you have. Let's connect this to the scientific method. The process of investigation is a constant interplay between 2 things. Inductive inference, making guesses based on observations, and deductive inference, making predictions based on existing theory. Our goal is always to get closer and closer to the truth. Here's a pragmatic point. Like in everyday life, we often accept that the usefulness of a theory is more important than its absolute validity. Time for a basic definition. What is inference? It is simply the process of deriving logical conclusions from premises that we know or assume to be true. In cybersecurity, inference is absolutely critical because it helps us to piece together information and make educated guesses when we are conducting investigations. The American philosopher C.S. Peirce summarized the 3 types of inference perfectly. Look at this slide. Deduction is the strongest. It proves that something must be. Induction is about probability. It shows that something actually is operative. Finally, abduction is the softest, but most useful for starting an investigation. It merely suggests that something may be. Remember, deduction proves, induction predicts, and abduction hypothesizes. Let's focus on deductive reasoning. This is all about deriving consequences from what we assume to be true. The great thing about deduction is that if your starting assumptions are correct, the truth of your conclusion is guaranteed. This approach starts with a hypothesis, and you predict what your observation should look like if that hypothesis is correct. It often follows the rigid logic of, if A and B, then C. Now for inductive reasoning. It's the opposite of deduction. Deduction goes from a general theory to specific observations. Induction flips that. It goes from the specific to the general. We make many observations, notice a pattern, and then infer a general explanation. This is often called empirical logic, because the logic is derived directly from our observations and experiences about the world. To elaborate on induction, we are essentially looking at many different specific examples and noticing recurring patterns. From this, we define a general law. Crucially, with induction, the premises support the conclusion, but they do not ensure it. Since each observation is a separate instance, the general rule is highly probable, but not absolutely guaranteed. Let's introduce the third type, abductive reasoning. This is the logic of forming the best guess. You use the best information available to infer the most likely explanation for something you can only partially observe. Abductive reasoning starts with accepted facts and works backwards to the most likely explanation. The key is that this hypothesis is not yet confirmed, but it seems to be a worthy candidate for further investigation. Think of abduction as forming your initial theory of the case, what we believe to have happened, the when, where, why, how, and by whom, all based on your initial observations. The most important rule when selecting an abductive hypothesis is that it must provide the most satisfactory explanation of the facts you are interested in explaining. When using abductive reasoning, keep these considerations in mind. First, you must collect data before you can form a hypothesis. Second, your abductive judgments can and will change as you get new information and focus on different leads. Finally, understand that abduction is the end result of induction, where you form the general rule, and it's the beginning of the deduction process, where you start to test it. Let's put all three types of reasoning into the context of an investigation. Remember, our goal is to establish exactly what happened and who was involved. Inductive reasoning helps you make initial hypotheses based on past experiences or observations. Abductive reasoning is what you use to pick the most promising guess. And deductive reasoning is how you test that guess. If your test consequences don't hold up, you know you need a new hypothesis. Why does all this logic matter? Because these three logic methods are the key techniques an analyst uses. The ultimate goal is to reach reasonable certainty about your conclusion. Remember the phrase, investigators must tell a convincing story about what happened, and that story must fit the facts and evidence beyond a reasonable doubt. Now, how do we get to forensic proof? It looks simple. 1. Gather data. 2. Make a general explanation. And 3. Use that explanation to prove others. But this is an iterative process. It keeps repeating. Here's a crucial legal and logical point. Each premise you establish must be accepted as true or fact reality before you can move on to the next valid conclusion. To achieve forensic proof, your evidence needs to meet high standards. First, every item of evidence must have a plausible relationship to your hypothesis. Second, the evidence itself must be authentic, reliable, and credible. And third, the integrity of your process, how you gathered and interpreted the data, is absolutely critical. This includes validating the forensic tools and the procedures used to handle the evidence. This slide presents the tests to achieve reasonable certainty. You need to ask tough questions. Are the people, tools, and techniques you used qualified and approved by a proper authority? Also, if you use any analogies or comparisons to reach a conclusion, have you performed a close examination and validation of the similarities between the things you are comparing? Let's summarize the roles of deduction and induction in a crime scene investigation. They are both required and complementary. Induction helps you at the start. You look at the initial observable data and use it to figure out the specific behavior of the offender. Deduction comes next. It requires testing and verification through experiments and crime scene reconstruction. The direction of your entire investigation comes from using both of these powerful methods together. To distinguish these inferences once more, inductive inference relies on observations over time, past experience, or formal studies of previous cases. Deductive inference is strictly focused on the case at hand, what is currently observed. Abductive inference is the bridge. It draws together past experience and the facts of the current case to generate that plausible explanation. This is a key concept in abductive reasoning. At its core, abduction is fundamentally about choosing between alternative theories. You start with several possible explanations, or paradigms, and use the evidence you have to determine which one is the most likely truth. This slide is a reality check. In any investigation, despite your best efforts and applying all the logical methods we've discussed, you must accept that sometimes you just cannot know. Investigations have limitations, and evidence isn't always complete. And that brings us to the end of today's lesson on logical inference in EInvestigations. I hope you now have a much clearer understanding of how to use abductive, inductive, and deductive reasoning to turn digital data into forensic proof. Remember, mastering these logical tools is what separates a good investigator from a great one. Don't forget to review your notes on the role of critical thinking and the need for evidence to be authentic and credible. Thank you for your attention, and I look forward to seeing you all next time.